Hey guys, I'm Manoj. Welcome to this chapter from the course C# and .NET for Beginners. I create contents for developers. Subscribe to my channel and press the bell icon to get the latest updates from this channel. In this chapter, we are going to begin our discussion with arithmetic operators. And after that, we will discuss about interesting concepts like arithmetic overflow and divide by zero situations. We will also have a brief introduction to the class System.Math. This class provides constants and methods which can be used in many mathematical operations. Then in the last part, we will discuss about bitwise and shift operators. I hope you watch this video till the end because, like previous chapters, there will be some exercises for you at the end. You can try those exercises on your own to make sure that you have grasped all the contents from this chapter. Let's get started. This slide shows multiple arithmetic operators. We already have discussed about these operators in previous chapters. The plus sign is addition operator. The minus sign is subtraction operator. The asterisk is for performing multiplication, while forward slash is for performing division. Now let's talk about the final operator, the remainder operator. The forward slash is the division operator. It returns the quotient from the division. But what if we want to know the remainder from the division? In that case, we can use this remainder operator. This operator is represented by the percentage sign. Sometimes it is also called as modulus operator. All these operators needs two operands to work on. And that's why these operators are called as binary arithmetic operators. These operators do not modify the value of their operands. They read the values from the operands, perform the operation, and then return the result. This returned result can be then assigned to a variable. Or alternatively, if this expression is nested inside another expression, then the result of the nested expression is used to evaluate the subsequent portions from the expression. This new slide shows a code example. Here, two integer variables have been declared. They have been initialized with some values. The remaining lines from the code snippet shows how the arithmetic operators can be used. In this code snippet, we are using only variables as operands of arithmetic operators. Instead of variables, we can also specify numeric literals as operands of these arithmetic operators. So for example, instead of using a plus b, we can also use 5 plus 10. Also, in this code snippet, we have used only integer data type. We can rather use any numeric type with arithmetic operators. So instead of integers, we can use long or decimal or double as the data types. The last line from this code snippet explains how multiple operators can be combined to form a complex expression. Now it is time for one interesting fact. I told you that we can use arithmetic operators with numeric data types, but we can also use arithmetic operators with char type variables. Can you guess why? Because character type values are internally integers. So if we apply arithmetic operators on character variables, then the operator will perform arithmetic operations on numeric values of those characters. And then it will return a result which is of integer type. Okay, let's move on. This slide shows another set of operators. The first operator in this list is postfix increment operator. We already have used this postfix increment operator when we were discussing about loops and jumps in chapter 6. This operator is represented by two plus signs after the operand. It increases the value of its operand by 1. Similar to this, there is another operator, prefix increment operator. It is represented by two plus signs before its operand, and it also increases the value of its operand by 1. There is one difference between postfix and prefix operators. The postfix increment operation is performed after executing the line of code which contains that operator. On the other hand, prefix increment operation is performed before executing the line of code which contains prefix operator. Similar to these increment operators, there are also decrement operators. The postfix decrement operator is represented by two minus signs after its operand, while prefix decrement operator is represented by two minus signs before its operand. Both of these operators decrease the value of their operands by 1. All of these four operators are categorized as unary operators. This is because these operators work on single operand. Also, unlike binary arithmetic operators, these unary operators modify the values of their operands. Let's have a look at the code snippet shown here. The variable is initialized with value 3. The second line is simple console.writeLine statement which displays the value of variable I. Hence, the output is 3 in this particular case. Then on the next line, there is another console.writeLine. This time, the parameter to this method is a variable I and there is a postfix increment operator applied to it. In this case, the console.writeLine will print the value of I, which is 3, and then it would increase the value of I by 1. So, on the immediate next line, if we just print the value of I, it should display 4. I hope this example helps in clarifying how the postfix increment operator works. Now let's have a look at prefix increment operator. The next 2 lines of code shows how the prefix increment operator works. There is one console.writeLine to print the value of I, but this time I has a prefix increment operator applied. As it is a prefix increment operator, the increment operation will happen first, and then the incremented value will be passed to console.writeLine. That's why the output will be 5 in this case. Did you notice the difference? In case of postfix increment operator, the console.writeLine was executed before applying the increment operation. On the other hand, in case of prefix increment operation, the increment operation happened before executing the console.writeLine. I hope this code example helps in understanding how the prefix and postfix increment operations work. On the subsequent lines, the usage of postfix and prefix decrement operators are shown. The same explanation applies to the decrement operators shown in this code snippet. On the next line, postfix decrement operator is used. So, console.writeLine would print the current value of I and then the decrement operation would happen. Similarly, on the last 2 lines, prefix decrement operator is used. So, in that case, the decrement would happen first and then the decremented value will be passed to console.writeLine. I hope you are following me. If you find these prefix and postfix operators confusing, do not worry at all. You can choose to avoid them while writing the code. You can simply use binary plus operator to increase value of any variable by 1, and it is perfectly fine. I brought these unary operators for discussion in this chapter because, in my opinion, it is better to know how these operators work. Knowing these operators would certainly help you in understanding the code that uses these operators. Okay, let's move on. There are 2 more unary operators, unary plus and unary minus operator. The unary plus operator returns the value of its operand as it is. On the other hand, unary minus operator returns the numeric negation of the value of its operand. So unary plus operator is equivalent to multiplying a variable by 1. On the other hand, using unary minus operator is equivalent to multiplying a variable by -1. As shown in this code snippet, if unary plus is applied to numeric literal 4, it would just return 4. But on the other hand, if unary minus operator is applied to value 4, then it would return -4. If 2 unary minus operators are applied as shown on the third line, then the innermost operator would return -4, and then this -4 value is used by the outer unary minus operator, and thus this nested expression would return the value 4. Note that these operators do not change the value of their operands, they return the changed values. So till now, we have covered all the important arithmetic operators, binary arithmetic operators as well as unary arithmetic operators. So let's move on. We already know that a single equal to sign is used as assignment operator. This operator can be used to assign some value to some variable. We have used assignment operator many times in previous chapters. This slide shows 2 statements in every row. The statements which are shown on the left side are the regular assignments, while the statements which are shown on the right hand side are the compound assignment statements. Each statement on the left hand side is equivalent to the corresponding expression shown on the right hand side. Let's take example. The first left hand side expression is a mathematical expression a plus b, and its result is assigned to variable a. This is how it is done using regular assignment operator. On the other hand, on right hand side, the compound assignment is used. The syntax for compound assignment is operand followed by addition operator followed by assignment operator equal to sign followed by another operand. This compound assignment means that perform the addition of a and b and assign the result to variable a. Both these statements, regular assignment statement and compound assignment statements, are equivalent. There is only one difference between the regular assignment statement and its corresponding compound assignment statement. The left operand is used twice in regular assignment statement. So the left operand is also evaluated twice. In case of compound assignment statement, the left operand is used only once. This means that it will also be evaluated only once. This behavior gives the compound assignment statement a little edge over the regular statements. Okay, let's move on. Till now, we have discussed all the arithmetic operators. I also have said that all those operators can be combined together to form a complex expression. This code snippet shows a mathematical expression. This expression uses many operators. The important question here is how this expression will be evaluated. What is the order of evaluation of the operators in this complex expression? For knowing the answer, we should know more about the operator precedence. This slide shows the order in which operators are evaluated. If an expression contains postfix operators, they are evaluated first. After that, if the expression contains prefix operators, then they are evaluated. After prefix operators, the multiplicative operators are evaluated if they are present in the expression. Multiplicative operators include multiplication, division, and remainder operators. These three operators have same precedence. And finally, if the expression contains additive operators, they are evaluated. Additive operators include addition and subtraction. The code snippet here shows a complex expression which contains many operators. Sometimes, if the expression contains many variables and many operators, then it may become hard to understand that expression. So, it may be better idea to use parentheses in the expression. Parentheses can be used to change the default order of precedence. The expression inside innermost parentheses are evaluated first. In this example, as written in the comment, the two parentheses which contains modulus operators are evaluated together. After that, all the additive operators are evaluated as they are inside the parentheses. And lastly, the multiplication is performed to arrive to the result. If you think that the complex expressions are hard to understand and they are not readable, then of course you have option to break down the complex expression into multiple simpler and smaller expressions. Okay, now let's move to the next important thing. We have seen that the operator precedence levels can contain more than one operators at a given level. And when any expression contains multiple operators from a given level, they will have the same operator precedence. In that case, the operators are evaluated based on operator associativity. Let's see what operator associativity means. As already stated, if an expression contains multiple operators which have same operator precedence, then operator associativity determines the order in which those operators are evaluated. There are two types of operator associativity. Some operators are left associative while some are right associative. All the binary arithmetic operators are left associative. It means that they will be evaluated from left to right. For example, let's consider this expression. It contains only two operators, addition operator and subtraction operator. Both of those operators have same operator precedence. As we have said, binary arithmetic operators are left associative, and that's why this expression is equivalent to the expression shown on the right side. The right side expression calculates the addition first and then it performs the subtraction, and it is because those two operators appear in that order from left to right. On the second row, there is another expression which contains two assignment operators. The expression is A equal to B equal to C. As the assignment operator is right associative, B equal to C would be evaluated first and then the remaining part of the expression is evaluated. I hope the concept of operator associativity is clear now. Let's move on to the next concept. Regardless of operator precedence, the operands are evaluated from left to right. This table displays some sample expressions in the left column. The right column in the table shows the order in which operands would be evaluated. As you can see, the order of evaluation is from left to right. For most of the rows, all the operands are evaluated before the operators. But in some cases, like in third and fourth row, some operands are evaluated and then some operators are evaluated and then again some remaining operands are evaluated. This is because sometimes runtime dynamically decides whether to evaluate further operands or not. To summarize, we have discussed everything about arithmetic operators. We also have discussed about operands and assignments. Let's move on. Before explaining next concept, let's have a look at exercise from chapter 5. This slide shows those exercises. The third exercise in particular was special. The problem statement says that program should take an integer value as input, and then this input integer value should be added to integer.max value. After that, we should display the result. In this problem statement, integer.max value is a constant provided by integer type. This is the maximum value that integer type variable can support. At the first glance, exercise seems to be fairly simple. We already have seen how to input a number. So let's exclude that part from our today's discussion. The crux of this problem statement is to understand what happens when we add any number to integer.max value. In this code snippet, we have declared a variable x, which is assigned to integer.max value. And then there are two console.write lines. The first console.write line displays the value of x, which is integer.max value. And then the second console.write line displays the result, which is generated after adding 1 to integer.max value. The commented area also shows the outputs that I got after running this code. As we can see there, the result of addition is negative. We know that integer.max value is a positive number. So how can be the result of adding 1 to a positive number is negative? How is this possible? Let's try to understand answer to this question. This horizontal line shows the finite range of integer values. When the result of any expression is outside the maximum allowed value, then the result is truncated by discarding any high order bits that don't fit in the destination type. And because of this behavior, when we tried to add 1 to integer.max value, the operation actually returned integer.min value. This situation and the behavior is called as arithmetic overflow. In a nutshell, every data type allows only finite set of values, and when the resulting value from an expression does not fit that range, then arithmetic overflow happens. The behavior of this overflow depends on the data types involved. The code snippet that we have seen on the previous slide shows the behavior in case of integer type. For double values, arithmetic overflow returns a special constant, Double.Infinity. This code snippet shows an example. Here, Double.max value is multiplied by a number, and this expression resulted into arithmetic overflow. If we print the value of the result, it shows infinity on the console. On the other hand, if an expression contains decimal type variables, and if that expression is resulting into arithmetic overflow, then the decimal type actually throws overflow exception. An exception is a runtime error. We have not seen what an exception is, so for now, we will not go into further details. Okay, now the other important thing. When a number is divided by 0, the result is non-deterministic. In C#, this is also a case of arithmetic overflow. And that's why, in this case as well, the behavior depends on the data type of the operands. The code snippet here shows some example of division by 0. When an integer type is involved and the divisor is constant and it is 0, then it is known at compile time, and that's why it would result in compile time error. If the divisor is not known at the compile time, and if while running the program the divisor becomes 0, then that particular line of code may throw divide by 0 exception. Next, when a double type is involved in a division by 0 operation, the result is infinity. Another interesting thing is, when a double value 0 is divided by 0, then the result of operation is NaN, which means not a number. Okay, this information is enough for understanding what is arithmetic overflow. Another important concept in case of arithmetic operations is rounding. Rounding is basically to replace a number with simpler and shorter number. The table given here shows various forms of rounding a number. The number can be rounded to its nearest integer value. Or if a number contains many decimal places, then it can also be rounded to use, let's say, only 2 decimal places. Otherwise, if a number is very big, then sometimes it is also rounded to use only few of the most significant digits. For example, instead of 23,220, we can just use 23,200. In programming, it is almost impossible to avoid rounding while performing many mathematical calculations. The rounding may occur due to how the mathematical operations are performed and how the floating point numbers are represented in the computer systems. The code snippet here shows 2 examples. Double value 0.1 is multiplied by 3, and then the code checks if the result is equal to 0.3. Ideally, it should be, but the equality check here actually returns false. Instead of double, if we use decimal data type here, the same operation would work as expected. meaning it would display true on the console. Why? Because decimal data type has more precision. The more the number of bits taken by a floating point data type, the more is the precision. In the second example, we have divided 1 by 3 and then the result is multiplied by 3 again. Ideally, the end result of these two operations should be 1. But interestingly, d is not exactly equal to 1, but it is very closer to the value 1. So, as I was saying earlier, it is sometimes impossible to avoid the rounding errors. We should always be very cautious about the precision that we need while calculating something. And for that, we should also be very cautious about deciding the data types to ensure that we get the required level of precision. Let's move on to the next topic. Let's have a quick introduction to System.Math class. This class provides multiple constants and methods for performing many mathematical operations. Some of those methods and constants are listed here. It provides constant pi, which can be used in many mathematical operations. It also provides a method ABS to find the absolute value of a given number. It also provides methods to find max and min from a given pair of numbers. There is also one interesting method, divrem. This method is very helpful if we want to know both quotient and the remainder from a division operation. Then there are also multiple methods for calculating logarithms. There is also a method to apply rounding to a given number. There are also some other methods which can be used to apply rounding to decimal point numbers. For example, there is a method floor which helps to calculate the floor of a number. The floor of a number is basically the largest integer value which is smaller than or equal to the given number with decimal point. For example, let's say the given number is 9.8, then the floor of that number is 9. Then there is another method to calculate ceiling of a number. The ceiling of any decimal point number is basically the smallest integer which is greater than or equal to the given number. For example, if the given number is 9.8, then the ceiling of that number is 10. There are also many other methods that are not listed here. I would suggest you to check the documentation for more details. Okay, this concludes our first section. Now, let's open Visual Studio and let's try to write some code. Let's try to write a basic calculator. A calculator allows you to enter the first number. After the first input, you can select the operation that you want to perform, and after that you can enter the second number. An operation will be performed on those two numbers and the result will be calculated. After that result is displayed on the screen, we can again select the operation that we want to perform and again enter the next number. This time, the selected operation will be performed on the previous calculated result and the next input number. We will try to simulate this behavior in our console application. We will ask for input number and then inside the loop, we will ask for operator and next number. In every iteration, we will calculate a result and then that result will be used as a number in next iteration. For now, let's say we want to keep this loop running for 10 iterations. So let's add a code which asks for input and then convert the input string into integer. Now let's add a for loop which runs from I equal to 0 till I is less than 10. Inside the body of this loop, we can ask for inputting the operation that user wants to perform. So for that, we will display the allowed operations by using console.write, and then after that, we expect user to press any single character. Although we expect a single character from the console input, I will use console.readline which accepts all the characters until user presses enter. So the data type of this choice variable will be string. Then we can ask for new input which is also a number. So now we have an operator and two numbers. So based on the input operator, we want to perform operation and that operation will also return the result. So let's use switch expression which uses choice as input and it can also return the outcome. This switch expression will contain 4 arms. If the choice variable is equal to plus character, then let's perform addition. If it is equal to minus, then let's perform subtraction. If the input operator is asterisk, then perform multiplication. And now the last permitted operation is division. But instead of specifying division operator explicitly, let's use discard symbol here. The discard arm will match to any input which does not match 3 previous arms. So if user enters any characters which does not match 3 previous arms, division operation will be performed. Ideally, we may want to write a stricter code. Ideally, our code should show an error if the input is not valid. But for the sake of this demo, let it be like this. Now, in the loop, let's display the calculated result and then add an empty console.write line to distinguish current iteration of loop from the next one. Now let's run the program. I enter 12 as first number and then plus operator as my choice of operation. Then if I enter 8 as the next number, the output is 12 plus 8, which is 20. Because of the for loop, it is again asking me to enter arithmetic operator. This time I enter minus and then I enter 9 as the next number. Surprisingly, it is showing 3 as the result, which in my opinion is wrong. Ideally, it should have performed 20 minus 9 and the result should have been 11. But I think it is performing 12 minus 9 and it is printing 3 as the result. So it seems something is wrong with our program. So let's come back to the code, and it seems that we have missed to assign the calculated result to first variable. Let's add it in our code so that in the next iteration, first variable will contain previous result. Now if we run the program again and provide the same inputs, we should not see any surprises. It seems the outputs are correct for addition, subtraction and multiplication. In every iteration, it is taking previous result as first number and then user can input the operation and the next number as input, and based on these three values, the arithmetic operations are performed. Now let's try to use division operator. It seems like our division operator is performing addition. Why? I think it is a copy-paste mistake. After copying the code, I forgot to change the arithmetic operator in the default case of switch expression. So let's come back to the code and change the operator here and now run the program again. All the operations should show the correct result. One interesting fact, if I enter any random set of characters instead of arithmetic operators, it would perform division operation in this case. It is because we have added division operation as a default case in the switch expression. Let's now take another code example. In this code example, let's take two integers as inputs and then perform the multiplication of those two integers and then display the result. Simple code, right? Do you think it would cause arithmetic overflow? Let's see. Let's try to run the program and let's try some random inputs. First, I will try very big number as input. And we can see that our application is broken. It is showing a runtime error. Currently, our application is running in the debug mode, and when an application is running in the debug mode, it goes back to the source code to show the line where the runtime error has happened. And that's why the control went back to Visual Studio, and we can see now that an overflow exception has occurred. Why? Because the input number could not fit into integer type variable, and that's why the overflow happened. Okay. Now we know that the first place where overflow can happen is type conversion. Let's run the application again. Let's try two big random numbers as inputs. We can see that the multiplication result is negative. Ideally, the result should have been positive as both the input numbers are positive. But in this case as well, the multiplication result was very big and it could not fit into integer type variable. So the high order bits were discarded and only last 32 bits were picked. And because the high order bits were discarded, the number became small and it became negative because the truncated result said the sign bit is equal to 1. I hope you find this code example helpful to understand the situations where overflow can happen. And as I said earlier, we should be very cautious about where overflow can happen and how to handle that overflow. We should also be very cautious about which data types we should use for calculations. Now, let's convert this same program to use division operation instead of multiplication. Will it cause any overflow? We already know that type conversion may cause overflow. So that is one point where arithmetic overflow can happen. Can division operation cause overflow? Well, if we divide a first variable by second, then the result of division is actually lesser than the first number. So I would say, ideally, division operator should not cause any overflow. Let's try to run the program and let's try some random inputs. Like let's say first input is 1 and the second input is 3. Our program displays that the output of this division operation is 0. Why? It is because the result of division is getting converted into integer value. Integer value does not support number with decimal points. So the result is rounded automatically to the integer value. Let's come back to the source code and typecast the result of division to decimal type. Now if we run the program again, the program correctly displays the output of division. Let's modify this program to understand how rounding works. So let's add calls to math.floor and math.ceiling to calculate floor and ceiling of division result. We can also use math.round to round the result. Math.round supports multiple overloads. we can use overload, which takes two parameters. The first parameter is the number that we want to round, and the second parameter is a value from enum midpoint rounding. This enum provides multiple values. We will use two values, away from 0 and to 0. Away from 0 means while rounding the numbers, always prefer going away from 0. And to 0 means exactly opposite. While rounding the number, always prefer to go towards 0. Okay, these statements are ready. Finally, we can also round the division result to use only two decimal places. For that, we will use an overload of math.round, which takes two parameters. The first parameter is the division result, and the second parameter is basically the number of decimal places that we want in the rounded result. And that's why we will pass the division result as the first parameter and 2 as the second parameter. Let's run the application. Enter 22 as the first number and 6 as the second number. We can see that the actual division result is closer to 3.67. When this division result is rounded to use only two decimal places, the result shows 3.67. The floor of 3.67 is 3 and the ceiling is 4. When this division result is rounded away from 0, 3.67 is rounded to 4. On the other hand, while rounding towards the 0, 3.67 is rounded to 3. I hope this code example was helpful. Let's move on to the next section. Every integer value is internally represented by a 32-bit binary value. For example, 0 is represented in binary as shown here. Every bit is set to 0. For representing -1, all the 32 bits should be set to 1 as shown in the second row. In fact, we can write a small code to display the binary representation of any integral value. For that, we can use convert.toString method. In this method, we can pass two parameters. The first parameter is basically the integer value, while the second parameter is the base of the system in which the number should be represented. The regular integral values support 10 digits from 0 to 9, and hence the base for regular integral values is 10. For binary, a bit can be either 1 or 0. And hence the base for a binary number is 2. So while calling convert.toString, the second parameter value should be 2. This method call returns a string which contains binary representation of the number. One important point to note is the returned value does not contain leading zeros from the binary representation. Another interesting fact, we can initialize any integer variable by using binary literal. The binary representation should be prefixed with 0b prefix. For example, integer value y is initialized with binary literal. The value has a prefix 0b underscore, and after the underscore there is 1 followed by 3 zeros. From this value, the prefix 0b is ignored and the rest of the bits are converted to integer value. Also, in the binary literal, the bits are grouped together into group of 4, and every group of 4 bits is separated from the others by using underscores. Anyway, coming back to the main topic, why are we suddenly discussing about binaries? Because we are going to talk about bitwise and shift operators. These operators work on individual bits. These operators can be used only on integral numeric types. The integral numeric types are the numeric types which do not support numbers with decimal points. So, the types like long, int, short, unsigned int, unsigned long, etc. can be used with bitwise operators. We are going to have a look at 6 different types of bitwise operators. Let's begin with bitwise complement operator. This operator is represented by using tilde character. When any integral value is prefixed by complement operator, it returns bitwise complemented result. Every 1 bit from the operand gets converted to 0 and every 0 bit from the operand gets converted to 1 in the result. Next two operators are shift operators. We can shift all the bits to the left by using left shift operator. This operator is represented by two angle brackets pointing towards left. The syntax is integral value or a variable followed by the operator followed by the number which represents how many bits should be shifted. In this particular case, 3 bits would be shifted to the left. The left shifting discards the high order bits that are outside the range of result type, and it also sets the low order empty positions to 0. We can also shift the bits to the right by using right shift operator. It is represented by two angle brackets pointing towards the right. It also has similar syntax. Integral operand followed by the operator followed by a number. The number on the right hand side of the operator indicates how many bits should be shifted to the right. This right shifting discards the low order bits. The behavior of high order bits depends on the type. For unsigned types, the high order bits are always set to 0. For signed types, the value of most significant bit is used to populate high order empty positions. There are 3 more operators. They are called as logical bitwise operators. The first one is logical AND. It is a binary operator and it needs 2 integral values. It returns the result which contains bitwise logical AND of the bits from its operands. At any given position, if both of the operands have a bit which is set to 1, then the operation sets 1 in the result at that particular position. Otherwise, the resulting bit is set to 0. The logical XOR operator is also a binary operator. It needs 2 integral values. It returns the result which is bitwise logical XOR of the bits from its operands. If at any given position the bits from both operators are not matching, then the resulting bit is set to 1. Otherwise, the resulting bit is set to 0. And finally, the logical OR operator returns the result which is bitwise logical OR of the bits from its operands. So if at any given position, if any of the operand has a bit which is set to 1, then the result will contain 1 at that particular position. I know these operators may sound confusing, and for understanding them better, we can now switch to Visual Studio and then try to use those operators in the code. Let's write a program to apply bitwise complement operator. So let's take an integer input and assign it to a variable with name first. Then apply the bitwise complement operator to that variable and then store the result in another variable. After this, let's add 2 console.writeLine statements to display the binary forms of input number and the result of bitwise complement operation. Okay, it seems the code is ready now. Let's run the program and enter 13 as input. The next 2 lines display the binary representation of input number 13 and its complemented value. Note that we have used convert.toString to get the binary representations of integer numbers. The output of that method does not contain leading 0 bits. And that's why our program is also not printing the leading 0 bits while representing the number 13. All those leading 0 bits have been complemented to 1 on the next line. Also, we can notice that all the positions where the number 13 had bits set to 1, all those bits have been changed to 0. I hope this code example helps to understand how the bitwise complement operator works. Let's try another code example. Let's write a code which reads 2 integers as input. Then it should ask user to choose a bitwise operation that user wants to perform. After that, the code should perform the selected bitwise operation on the input numbers and then display the result. So let's start coding by taking 2 integers as input, then add console.writeLine to display the instructions for the user. The instruction says that user can enter 1 for left shifting, 2 for right shifting, 3 for bitwise AND, 4 for bitwise XOR, and 5 for bitwise OR. After this, we can add code which reads the integer value from the console. This integer value represents the user's choice. Here as well, we can use this choice as input in the switch expression. The switch expression can contain multiple arms. Each arm should correspond to a valid input value from 1 to 5. The arm corresponding to every valid input will perform the respective bitwise operation. Here is the switch expression and the code inside it. In this switch expression, we are going to use a discard pattern for matching all the invalid inputs. And for all the invalid inputs, our switch expression will return value -1. I am highlighting this again that this code in the discard arm is not appropriate. Ideally, if the input is not valid, then the code should show the error message to the user and it should ask user to enter a valid input. But for the sake of this demo, we are not going to do that. We will just return -1 if the inputs are invalid. This switch expression would also return a value which is result of the bitwise operation. Let's keep that value in a result variable. And finally, let's add few console.writeLine statements to print the binary representations of first input number, second input number, and the result of bitwise operation. It seems our code is ready. So let's run the program. If we perform left shifting operation on input 8, and if we try to shift the bits by 2 positions, then we can see that 2 most significant bits should have been removed and on the right hand side, there should be two 0 bits appended in the result. Now let's use the same inputs and let's try to perform right shifting operation. Here we can see that the two rightmost bits have been removed. To understand what is happening with the high order bits, let's try to input the negative number now. Let's say we enter -10 as the first input and 2 as the second input. And let's say we select right shifting operation. In the result, we can see that last two bits have been removed and the leftmost bit is used to populate the additional two bits that are added on the left side. As we have seen in the theory part, the behavior of right shift depends on the data type. Because integer type is a signed type, whenever we perform right shifting on integer type, the value of the highest order bit is used while populating the extra bits that are inserted due to right shift operation. Let's run the program again and let's input -100 and -200 as inputs. After that, select the bitwise AND operation by entering 3. Here I have intentionally used negative numbers so that we can see all the 32 bits in the binary representations of input numbers. On the result line, we can see that at any given position, a bit in the result is set to 1 only if both the inputs had 1 at that particular bit position. Okay, let's run the program again. This time as well, enter the negative numbers -125 and -250 and select bitwise XOR operator. Here, a bit at a given position in the result is 1 only if the bit values in both the inputs at that particular position are not matching. If they are not matching, then the result contains 1 at that particular position. If the bit values are matching, then the result contains 0 at that position. And as we can see, the result actually contains lesser number of bits. It is because all the leading 1 bits have been converted to zeros and our code ignores the leading 0 bits while displaying the binary representation. Okay, now let's run the program again and this time enter any two numbers as inputs and select the last operation, the bitwise OR operation. In the result of this operation, a bit at any given position is set to 1 only if any of the two input bits at that particular position is 1. I hope that this code example was helpful to understand how bitwise operations work. Now, let's try another problem statement. Let's try to write a code which reads a number as input. Then we should count the number of 0 bits in that number and then display the count. This time, the count should also include the leading 0 bits. We have an option to use convert.toString to get the binary representation of the input number, and then we can loop over that string to count the number of 0 characters in it. Instead of that, we will use binary operators. Let me first explain the approach. We can start with a temp number which contains only a single bit which is set to 1, and that bit should be the rightmost bit. Then we can perform the logical AND operation of the input number and the temp number. If the value of the rightmost bit in the input number is 1, then the result of bitwise AND operation would not be 0. In that case, we should increase the counter. Otherwise, we should not change the counter value. After this, we should apply left shifting on the temp variable. We should shift the bits by 1 position and then keep doing these steps 32 times because integer contains 32 bits. But wait, using this approach, we are counting the number of bits which are set to 1 and our problem statements wants a solution to count the bits which are set to 0. What can we do now? We can just complement the input number by using bitwise complement operator. That way, all the 0 bits will be converted to 1 bits and all the 1 bits will be converted to 0. And then we can apply the logic to count the number of bits which are set to 1. So let's add a code to take a number as input. After that, declare a temp variable and set its value to 1. In integer value 1, only the rightmost bit is set to 1. All the other bits are set to 0 and that's why we are using that value. And then we can apply the bitwise complement operator to input number. We can store the result of this operation into the input variable itself. After this, we can add a for loop which runs from I equal to 0 until I is less than 32. Inside the body of this loop, perform bitwise logical AND of input and temp. If the result of this operation is not 0, then increment the counter. Then left shift the bits from the temp variable by 1 position and store the result of this operation in temp variable. Finally, after the loop, display the value of the counter. Now let's try to run the program. Enter value 16, which contains only one bit which is set to 1. So all the remaining 31 bits should be set to 0, and our program correctly prints that the count of 0 bits is equal to 31. Let's give another try and let's run the program again. This time, let's input 5. The output of our program says that there are 30 bits in this number which are set to 0. It is correct. This is because 5 is represented in binary as 101. It contains only 2 bits which are set to 1. So all the remaining 30 bits are set to 0. So it seems that our program is working as expected. I hope these code examples were helpful. Let's move on. Let's now move on to the final section of this chapter. This section shows exercises that you should try on your own. In the first exercise, take a number as input and then apply bitwise operators to count the number of bits which are set to 1. Finally, display the count. In the second exercise, read a number as input and then print true if the number is power of 3. A number is power of 3 if it is result of exponentiation with 3 as a base and some number n as exponent. For example, your program should display true for numbers 3, 9, 27, 81, etc. because they can be calculated by using power of 3. But the program should display false for numbers like 6, 42, 45, etc. In the third exercise, read a number as input and then use division operator and remainder operator to reverse the digits in that number. After that, display the result. In the fourth exercise, ask for two numbers as input. After that, ask user to input any arithmetic or bitwise operator as input. Then, apply the input operator on the two input numbers and display the result. You can use switch expression or if statements to calculate the results. You can also add iteration statements to keep the program running until user wants it to run. Alright guys, that's it from this chapter. Thanks for watching. If you found this content helpful, like this video and subscribe to the channel. If you have any feedback or suggestions, please let me know via comments. Alright, see you in the next chapter. Namaste.